How does JavaScript remember variables, even after a function has finished executing? The function is gone, but the data is still there. This behavior powers private variables, async callbacks, and even modern frameworks. It's called a closure. Let's look at this example. We call outer, it creates a variable called count, and returns the inner function. Now here's the strange part. Every time we call counter, the value keeps increasing. 1, 2, 3. But outer has already finished execution. So why hasn't count been removed from memory? Normally, when a function finishes, its memory should be cleaned up. That's what we expect, but this assumption is wrong. Because in this case, the memory is still being used. To understand this, we need to look deeper. When a function is created, JavaScript doesn't just store its code. It also stores its surrounding variables. This structure is called the lexical environment. Now when the inner function is created, it keeps a reference to that environment. Not a copy, a reference. Let's go step by step. First, outer is pushed onto the call stack. Memory is allocated, and count is stored. Then the inner function is created. And here's the key detail. The inner function is linked to the memory of outer. Next, outer finishes execution, and is removed from the call stack. But the memory is not destroyed, because something is still referencing it. And as long as a reference exists, JavaScript's garbage collector will not remove that memory. So when we call counter, it accesses the same count variable. This is what a closure really is. A function, combined with a reference to its lexical environment, even after the outer function has finished execution. This behavior allows us to create private variables. Here, balance exists inside the function, and cannot be accessed directly from outside. Only the returned functions can interact with it, because they form closures over that variable. This is how JavaScript achieves encapsulation, without exposing internal state. Closures also explain asynchronous behavior. The greet function finishes immediately, but the callback runs later. Still, it remembers the variable name, because the callback holds a reference to its original lexical environment. Now let's look at a common issue. Using var, all callbacks share the same variable, so they all print the same value, because they reference the same memory. But with let, each iteration creates a new lexical environment, so each callback gets its own variable. That's why the output becomes 0, 1, 2. Let's clear a few common misconceptions. A closure is not just a function inside another function. It's about retaining access to variables. Variables are not copied, they are referenced. And memory is not immediately cleared, closures can keep it alive. Closures are not just a concept. They are a fundamental part of how JavaScript works. They control how memory is retained, how asynchronous code behaves, and how data can be encapsulated. And here's the key idea to remember. Execution contexts come and go in the call stack, but the lexical environment lives in memory, and the inner function keeps pointing to it. Once you understand closures at this level, JavaScript becomes much more predictable. And if you like simple explanations like this, subscribe for more.